Hi, everyone. I kind of wanted to give you an idea as to maybe why you're seeing Mod 5 Part 1. Why isn't it just completely Mod 5? So Module 5 actually works best by splitting it apart and putting Mod 6 in between. So that's why we're going to start with Mod 5 Part 1. This is only going to be one day, which is this video. And it's actually pretty much all review. From either Math 2, you guys are going to see trigonometry again, like sine, cosine, and tangent. And then there's also a little bit of volume in there, which you guys learned in middle school, and a little bit in Math 1. So today is going to be all review, and then this will kind of basically, it will be like a good intro into Mod 6, and we'll start Mod 6 right away the next video that goes up, okay? So yeah, so this is just gonna be one day, modified part 1. We're just gonna like pick and choose important things, especially because it's mostly review, and then I will tell you what your entire homework is, all right? So we are going to start with reviewing some trig. So here we are. So if you guys remember, you learned this in Math 2. We can only use trigonometry in right triangles. So as you can see here, we have to be given some kind of chosen angle. So for example, they will label that angle for us. And then the side that is completely across from it is called the opposite side. The side that is next to it or touching that angle is called the adjacent side. And then the side that is the longest side across from the right angle is called the hypotenuse. So that's a good little review. I will say like OAH for short. And then we always take sine, cosine, and tangent of a particular angle. So you'll either say like the letter A, like angle A, or this symbol, which is theta. It's just a Greek symbol that's used a lot in math to identify angles, to name them. So we're going to take sine of theta, cosine of theta, and tan of theta. So to remind you, there's a little acronym to help you remember, and it's SOHCAHTOA. So for sine, that's what the S is. Sine is equal to opposite over hypotenuse. That's where you see the O and the H. And then C is for cosine. So cosine is equal to AH, which would be adjacent over hypotenuse. And these are, of course, the side lengths, the opposite side over the hypotenuse side. And then finally, T is for tangent, and that's equal to OA. So it's going to be equal to the opposite side divided by the adjacent side. So we use SOHCAHTOA to remember. So I hope that was a good little review and things are kind of coming back. We're just gonna make sure that it's all there and we do remember. So if you guys want, you're welcome to pause the video and figure these out just to see if you remember. So if we do sine, it is the opposite side over the hypotenuse and it's from theta. So we wanna point to theta first right here. And the side opposite to it is 3. So it's going to be 3 over, and then the hypotenuse is across from the 90. But it's not labeled. Interesting. Well, another little reminder, flashback for us. In a right triangle, if we're given 2 sides, how do we find the third side? Pythagorean theorem. So a squared plus b squared equals c squared. The c is always the hypotenuse, always the longest side. The a and b are just the other 2 sides. We call these legs, and you can switch them. It doesn't matter if you say 3 squared and then 4 squared or 4 squared then 3 squared. So 3 squared plus 4 squared equals c squared. 9 plus 16 equals c squared. 25 equals c squared. We want to know just what is c equal. Square root of 25 is 5. There's no plus or minus because you can't have a negative measurement of a side. So this hypotenuse is a 5. So we found that using the Pythagorean theorem. You guys we were probably taught in math too about Pythagorean triples. So anytime you see a 3 and a 4, this will always be a 3, 4, 5 right triangle. So this is, so sine of theta, the ratio is what this is called for theta is 3/5. So that would mean cosine adjacent over hypotenuse, because ca, and that would be 4/5. And that's it, like that's your answer. That's what it represents. And then finally, tan is opposite over adjacent. So from theta, opposite over adjacent, that's 3/4. Okay, so that's just a good little reminder of how to write the ratios. Sometimes you might be given it as a word problem. If that's the case, I would always draw a picture. And then it doesn't matter where you guys label theta, but you do need to label theta. So I'll put it down here. And see how it says that sine is 4/7? Well, sine is opposite over hypotenuse. So I'm going to put 4 as my opposite side from where I labeled theta. So here's theta, so my opposite side is here. So I'm going to put a 4 there. And my hypotenuse is 7. Then I would do the Pythagorean theorem to find this third side. Then I would find tan. So that's how you guys would do it if it was given to you as a word problem and not necessarily a triangle right away. All right, so that's your first little trig review. This right here is more review as well. So we can use trig to find missing side lengths. So for example, if we look at these two right here, they are asking us to use trig ratio to solve for the value of x. And we're gonna round to the nearest 10th. Okay, so if we look at this first problem here, this is essentially my theta. This is the angle that you guys want to use. You will never take trig of the 90-degree angle. It'll always be one of the acute angles, okay? So here's my angle. Now, what am I given? I'm given this x and this 18. I don't care about this side. Who cares? We're trying to find this side. So in terms of opposite, adjacent, hypotenuse, what of these three do we have? Well, we have our angle, we have the opposite side, and across from the 90, we have the hypotenuse side. So in this picture, if I have the opposite and the hypotenuse, which trig do you think we should use? Sine, because it has opposite and hypotenuse. It's the only one with opposite and hypotenuse. So that's why we're going to pick the sine instead of cosine or tan. So we're going to pick sine, and we're going to take sine always of the angle, which in this case is 55. Setting up our equation, that's why it says use the trig ratio to solve. So that is equal to opposite over hypotenuse. What's my opposite? It's unknown, divided by my hypotenuse, 18. Okay. Then I like to put this guy over 1, and then I see it as a proportion. So I'm going to cross multiply. So x times 1 is just x. And this is 18 times sine of 55. Okay. And then we can go ahead and calculate it as a decimal because they want it to the nearest 10th. Do you guys see how this is in degrees? So this is really important, whether you're using your iPhone or a calculator. Make sure it's in degree mode. See how mine says DEG? Yours might say a D, but if it says an R, that's a different thing. So on my calculator, the way you would change that would push this DRG button. And there it is, that's degree. I would go over here, oops, sorry. I would go here, and that's called a radian. You guys actually learned about these in Math 1, and we're gonna be dealing with these in Module 6. So if I enter that, see how it now says RAD? Some calculators might just say R. So for this portion of Mod 5, it should always be in degree mode, okay? If you have a calculator different than mine, feel free to Google it, like how do you change my calculator, TI, blah, 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 into degrees or into radians, and that might be helpful, okay? Okay, I should probably leave this over here. So I'm going to calculate this guy. So we're going to do 18 times, and then just be careful with parentheses and such. This one isn't too bad because it kind of already opens up the parentheses, but just be careful. 55, and that is equal to, now they said to round to the nearest tenth. So the nearest tenth is one place after the decimal point. And because this is a 4, we don't round up, it stays a 7. So our final answer is 14.7. If this was a 5 or higher, we would have rounded it to 14.8. Okay. You can say approximately or equal to. I'm not going to be picky on that. And it's 4.8. I'm not particular about units either, but if like this had said inches or something like that, your final answer, of course, would be in inches. Okay. All right, so if you guys want to pause the video, go ahead and try this next one. And I'll come back with an answer if you want to see if you're right. Okay, so if you did it right, you should have gotten 5.7. If you did not get 5.7, let's figure out why. So to start, here's the angle I'm working with. I'm given a 4, that's the opposite side, and this x, that's the adjacent side. I have, the h is not labeled. Hypotenuse is not labeled, so I'm not going to be using sine or cosine. That's why I chose tangent. So that's how you know that it was tan. So we do tan of our angle, 35, equals opposite over adjacent, 4 over x. Then you can put the tan over 1 and cross multiply. And you'll see this time compared to this one, this was x times 1, so it kind of just solved itself. This one, you're multiplying the tan by the x to get you to here, okay? Our goal is to get the x by itself, so because x is being multiplied by tan, you're going to divide both sides by tan of 35. So then these cancel, and now my x is alone. So that's how I got x equals 4 divided by tan of 35. And when you punch that into your calculator, you should get 5.7. So again, this is all review from Math 2. I do think it's important to still go over it with you guys and actually explain it. But I'm not going to spend the whole world on this because you've already learned it and been tested on it. Okay, and then the final thing for this part that is review is to, instead of finding a side length, like do you guys see how the x value is always a side length? Down here, your x value or question mark is an angle. So this time we're going to find an angle. Let's see if you guys remember this. So it's pretty similar to what we just did. So we're going to identify, here's our angle. So what two sides are we given? We're given the 27, which as you guys can see is the opposite side. And we're given the 38, which is the adjacent side. So because I have an O and an A, what should I use? Sine, cosine, or tangent? I should use tangent. So I'm going to take tan of the missing angle, which we don't know what it is, and that's equal to opposite over adjacent. And then instead of cross multiplying and solving here, we're not going to do that because the question mark or the x value isn't over here, it's here. So how do you guys get this completely by itself? Well, this kind of goes back to module 1. You guys remember inverses? So if I have an x and I multiply it by a 3, how do I undo that? How do I get rid of that? I divide by 3. It's gone, right? So that's kind of what we're doing here. I want to get this question mark alone, but it's currently having tan taken over it. It's not times tan, right? You don't divide by tan. That's not how this works. This is tan of question mark, not tan times. So how do I undo this tan of question mark? I take the inverse of the whole thing. And that crosses these guys off, and my question mark is now alone. Okay? So again, you have seen this in Math 2. If I took tan inverse on the left, I do need to do it to the other side. So I will be taking tan inverse of this as well. So that means that question mark is equal to inverse tan of 27 over 38. So I got question mark alone, and now I need to calculate this. Notice how in the directions it says round your answer to the nearest whole degree. So pay attention to directions. That's going to be really particular on tests. So this says the whole degree, so I don't want any decimals. So round up to the nearest whole degree. And then your answer is a degree because you're finding a missing angle. Okay, so let's go ahead and calculate this. So if you guys see for mine, I have sine, cosine, tan buttons, but right above it is the tan inverse button. And that's kind of that light blue color. So to get to that, because if I just push tan, it's just tan. But to get to the button above it, I have to push second first. Some of your calculators might say shift. I'm gonna do second, tan, and there's tan inverse. And I'm taking tan inverse of 27 over 38. So 27 over 38, close parentheses. And what does that equal to? 35.3. Does this 3 round this up to 36? Nope, so it's just 35 degrees. So question mark is approximately 35 degrees. Okay. If you want to move on, you can. I'm only going to put the answer up on this one. I'm not going to show all my work. If you guys want to try it really quickly, you will get practice on the homework. But if you want to do this guy really quickly, go ahead and pause the video. And if you did it correctly, you should have gotten the answer of 24 degrees for that one. Okay. All right. So now that we have a good understanding and hopefully a reminder of that, we're going to put this into word problems, which again, you guys did see in Math 2. So you will have a word problem. For me personally, I just always draw the same triangle. I just always draw a right triangle like that, okay? No matter what the problem is. And then I fill in everything. Now, you're gonna notice that there is a particular phrase in these word problems. It's either gonna say angle of depression or angle of elevation. So it actually ends up being the same angle. So I always put that angle right here every single time. But I kind of just want to go over this really quickly so you guys can understand why they're actually the same. So for angle of elevation, if you guys are looking straight ahead, right? So you're standing up and you're looking straight ahead. See how it is parallel to the ground, right? So your eyes are looking straight ahead. And then when you elevate, what does it mean to elevate? To go up, right? So that means that now you're going to take your eyesight that was parallel to the ground and you're now going to tilt your head up to elevate. So if you tilt your head up, where's your eyesight now? Going up, right? So this angle right here that gets created from your initial line of sight, and then when you look up, that right there is the angle of elevation. And then if we connect these two together, there's your right triangle. So the angle of elevation will always be the one looking up. Angle of depression, instead of looking up, you're actually looking down. So usually you're already like off the sea level or whatever, if you will. So like it could be like, oh, you're on a cliff, or you're in a hot air balloon, or you're in an airplane, something like you're up high. Okay, so again, this is you. Okay, and then we're going to actually start this the same way we did with angle of elevation. You're first looking straight ahead. We always need that parallel, okay? So you're first looking straight ahead, then you're going to take your eyesight and look down. So that goes like that, right? So this right here is your angle of depression. So there's that right triangle. Now, I don't like to draw this upside down triangle thing. I like to have my triangle look exactly like this. So what I do, you'll actually see why it ends up being the same triangle anyway. Oop, I didn't mean to zoom in. I wanted to brighten. There we go. So I'm going to draw a square, or a rectangle actually. Okay. And by definition of rectangles, again, Math 2 review again, these are parallel, right? And these are parallel. And then this guy cutting through right here, that's called a transversal line. And so by definition of parallel lines in a transversal, this angle is congruent to this angle. And they're congruent to each other by alternate interior angles. Is that kind of coming back to you? So instead of using this upside down triangle, I'm going to use this right side up triangle. It's still a right triangle, and this time my angle's down here, which is how I drew it here anyway. So you guys can see that actually the angle of elevation and depression end up being that same angle looking up. A common mistake a lot of people will make is they will draw this triangle, but then they think, hey, angle of depression, that must be this one, but it's not, because where is that horizontal line of eyesight? So this angle here is not the same as this angle, not the same. If you'd like to, you can do 90 degrees minus that angle of depression to get to this angle, that's fine. But I'm just always going to be drawing the same triangle and always putting my angle of depression or elevation down here every single time, okay? And you won't make mistakes. Okay, so let's kind of label this. So we have a hiker. He walks to the edge of a cliff and looks down at the scenery below, right? So that's why it's an angle of depression. So here's your hiker. This is technically his angle of depression, but by alternate interior angles, I'm going to make this the angle of depression. All right. He spots another hiker down below on the flat ground that's 200 feet. So here's the other hiker on the ground, and he is 200 feet from the base of the cliff. So if this was the cliff, right, this is the cliff, then the base of it is right here. So if he's 200 feet away from the base of the cliff, that would be this length right here. So this length is 200, not the hypotenuse. They didn't say from the top of the cliff to the hiker down below, that's 200. No. They said from the base of the cliff. So that's 200. And then it says if the angle of depression is 36. So again, you can put it up here, but then alternate interior angle. So I can actually put it down here, it's 36 degrees. And then there always has to be a variable. So what is the question asking? What is the height of the cliff? So how high is the cliff? That's what we're trying to figure out. How big is that? Okay. So now that we have this picture drawn, we can now use Trig and go from there. So if you want, I'll redraw this so it's not so messy. So now this is like what we just did on the previous page. So I have an angle. Now from that angle, what two sides do I have? I have the opposite side and I have the adjacent side. So if I have an opposite and adjacent, do I use sine, cosine, or tangent? I use tangent. So we're going to take tan of my angle, 36, and set it equal to the opposite over the hypotenuse. And then we would solve away. So we're going to cross multiply, calculate. This doesn't specify what to round it to. The directions on the test always will though. So let's just round it to the directions that said from the previous page, which was to the nearest 10th. So if we were to round this to the nearest 10th, you guys should get 145.3. And then because this is a word problem and it said this was 200 feet, if you really want to be particular, this would be in feet as well. So the height of the cliff is 145.3 feet, roughly. Okay, so that is our review from Math 2 in terms of trigonometry. And you'll get some more on the homework. Let's go ahead and move into the next part. This will be quick. So We're actually going to be reviewing volumes, which we learned in, I think it was 8th grade. So I know it's been a while. On Google Classroom, I'm going to be posting this resource page, a formula sheet. We are not going to be covering this really. It's just there as like a good reminder. So the perimeter is like the outside of a rectangle or a square. Circumference is the outside of a circle. We're not really going to be talking about surface area at all. These ones, you guys should have these memorized by now. This is not going to be given to you. You should know what the area of a rectangle, triangle, and circle are. But what is going to be given to you on the test is volume formulas, okay? So we have the volume of a prism, a pyramid, a cylinder, a cone, a sphere, and then this new guy called a frustum. This says that the big B stands for the area of the base, okay? So that's why you guys don't see a little b here. It's not the base times height. You're not taking the area. It's a volume formula. So you need to do base times height and then times another height, or length times width times height. Okay, so again, I'll have this posted on Google Classroom for us. So let's just do a little bit of review here. We are going to start with let's just do the frustum because that's the new one. Okay, so let's do this guy. Okay, so the best thing I kind of relate to a frustum is like a lampshade. That's probably the closest real life frustum that you guys see. I'm going to go ahead and rewrite the formula for us, again, which is on that resource page. So the formula for a frustum is pi times height. That's the height of the frustum, so like how tall is it? Sorry, I had to plug in my computer. Okay, so pi times the height divided by 3. And then that whole thing's being multiplied big R squared plus big R times little r plus little r squared. Big R stands for the radius of the bigger circle, and little r stands for the radius of the smaller circle. So as you guys can see over here, picturing that this is the lampshade, these are circles. I know they look like footballs, but it is a circle. So this is a bigger circle right here. So we want the radius of the bigger circle, and then this is the smaller circle. So it's really just about applying like, just like filling in the formula and simplifying correctly. That's it. This is not that complicated. Okay, so we're gonna do pi times, now what is the height of the frustum? So height, you always measure height vertically, right? Like if you want to see how tall you are, do you guys stand at a slant and then they measure you? No, you stand up straight and then they measure you. So it's always a vertical thing. The vertical height in this case is here, which they tell us is 10 centimeters. So that's the height. I'm dividing by 3, and then we're multiplying it by big R squared. So big R is the radius of the big circle down here. So the radius is from the center to any point on the circle, and that's 6 centimeters. We're going to do 6 squared plus big R, which is 6, times little r, which is the radius of the smaller circle. So up here, the radius is 2. And then plus 2 squared. And then from here, we just simplify. Simple as that, okay? So this becomes 10 pi over 3 times 36 plus 12 plus 4. That all added together is 52. So this becomes 10 pi over 3 times 52. We can put it over 1 if you'd like. And then we always multiply straight across. But you guys are also welcome to simplify if you can, but we actually can't. 10 doesn't go into 3 and 52 doesn't go into 3. So we do have to multiply numerator with numerator, denominator with denominator. So 10 pi times 52 is 520 pi divided by 3 times 1 is 3. And you are welcome to leave your answers in terms of pi. I don't need you to click the pi, multiply this by pi. So I'm totally fine if you leave your answer like that. If we're going to be picky, in terms of units, this would be centimeters. And then because it's volume, if you guys remember, area is squared, perimeter is to the first power, volume is always cubed. So this is 520 pi over 3 centimeters cubed, or cubic centimeters. If you were to find the decimal version of this, you guys don't want to do, so I would do 520 over 3 first, okay? And instead of multiplying that by 3.14, multiply it by the pi button. Every calculator has one, because that'll give you a way more accurate answer. So it's approximately 544.5 centimeters cubed. Okay. All right. Quick little volume lesson. So where do actually 3D figures even come from? So we can create 3D figures from a 2D figure. So if we start here, this is just going to be a quick little thing. So this shape right here, this is a rectangle, right? Now, if we take that rectangle and we spin it so fast, you're actually going to see a shape, right? Just like, watch, if I take this pencil, I'll actually leave it on, and I spin it really quickly, around and around and around and around and around and around. What shape am I getting? A circle, right? Even if I put my pen down and I spin it, I would draw a circle. So when you turn things, you get circles. So you guys can rotate it either about the x-axis or the y-axis. So if I take a rectangle and I spin it or rotate it around, let's do the x-axis. So that's here. So I'm basically going to reflect it over the x-axis. Okay. And then because the x-axis is horizontal, I'm going to spin it around. Spin, 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 spin. So if I'm spinning this guy over and over and over and over and over again, when I turn this, I get a circle shape, right? And then where do you guys see the circles when I turn a horizontal line? Right here on the sides, right? So if I spun this around the x-axis over and over and over again like this, it would create circles here and here. So this is now a 3D shape. And what shape is this? Cylinder. So cylinders actually come from the 2D shape of a rectangle. So a cylinder is just a rectangle that has been spun around multiple times. We can actually do this with the y-axis as well. So let's now flip it around the y-axis. So I'm first going to reflect that same rectangle over. Like so, okay? And then I'm going to take that and I'm going to keep flipping it, flipping it, and flipping it, and flipping it, and turn, 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 turn. Now see how I have a vertical line this time that I'm turning instead of a horizontal line? So if I have a vertical line that I'm spinning, 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 turning, 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 where do you guys see the circles being drawn? On top and bottom, right? Instead of side to side, they're on top and bottom. So these circles are here. It's still a cylinder, but the circles are now on top and bottom. So this cylinder is like facing upwards, like think of like a tuna can. And then this cylinder is like, picture a soup can that fell over. Okay. So it just depends on what axis they want you guys to spin it around. And that's how you get that 3D shape. So a cylinder is just a rectangle spun around one of the axes to become 3D. Kind of cool, huh? We're gonna do the same thing with a triangle. So if we spin a triangle around the x-axis, so again, I'm first gonna reflect it over the x-axis. X-axis is horizontal, so if I spin, 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 where's the circles being drawn? Here on the sides, right? This doesn't give me anything, so I just have a circle here. What shape is that? A cone. So a cone is a 3D shape started from a 2D right triangle. Kind of neat. And then we can also spin this guy around the y-axis. So first I'm going to reflect it. And then I'm going to spin, 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 spin. So this guy looks like that. Okay. Let's try a problem together. Let's do number 5. So this is number 5. And it says to rotate the shape around the x-axis. So here's the x-axis. So we're going to rotate around the x-axis. And then I want you to find the volume. Okay, so go ahead and pause the video and try that out. Okay, so if you've done it, we reflect over the x-axis to get to here. And when we spin the shape over and over again, the circle ends up going here. So there is your cone. And you guys are always welcome to redraw it if it's helpful. Okay. And then you should have found the volume. So the volume of a cone, which again is on this sheet, is this guy. So see how it says 1/3 big B H? Well, big B is the area of the base. The base shape is the thing sitting on the ground. So a circle's on the ground. So what's the area of a circle? Pi r squared. That's why it says this. So the volume is pi r squared because it's the area of the circle, and then times the height of the cone. That's how it becomes 3D. Get that volume shape. Okay, so how do we get these dimensions? Well, what's the height of this cone? If we look back here, don't include this piece, but it's from here to right there. So that's 4. The height is 4. And then I also want to know the radius of my circle, which is here. So that's 2. Okay, so to find the volume of the cylinder, we do pi, and then the radius was 2 squared times the height. And then we simplify it, so that's just 4 times 4. The volume is 16 pi. And if they don't give you units, you guys can just say units cubed. That would be fine if you weren't told any sort of units. Okay. And I totally forgot the 1/3. Dope. 1/3. Figured something was wrong, so I'm just going to divide this by 3. That fixed it. If I didn't divide it by 3, that would be if this was a cylinder. That would be a cylinder, but because it's a cone, we divide by 3. So you guys can leave your answer like this because I can't simplify 16 over 3. The decimal version, you would do 16 over 3 first, and then again multiplied by that pi button. Okay. So that is the volume of this cone. Okay. The last thing we are going to do is number 9, and then we are completely done with Mod 5 Part 1. Oh, so it says shade the region bounded by the lines. That should actually be plural. So there's 1, 2, 3, 4 different lines that we are going to draw. So here is the first line. It's in y equals mx plus b form. So here's your b and there's your slope. So let's go ahead and plot that. So 10's the y-intercept, and we go down 1 unit over 2, down 1 over 2. Okay. I'm going to use a straight edge coaster because I don't have my ruler. So there's that line. Next one is the x-axis. I'm just gonna redraw the x-axis because that counts as a line here. Okay. The equation for the x-axis is just y equals 0, if you remember. Next line we're gonna draw is x equals 2. When it's just an x, that's a vertical line. So we're gonna draw a vertical line through the number 2. Okay. And then the final line is another vertical line through 8. So I have a total of 4 lines, and they say to shade the region bounded by this. So think of these as like a fence. So like, what's your like gated area? And that would be all of this. So that is the region bounded by those 4 lines. Does anyone know what shape this is? So that's a trapezoid. Now, a trapezoid is a 2D shape, right? I don't need you to find the area though. We're gonna rotate this around the x-axis, and you guys are gonna find, as it says, that the 2D shape of a trapezoid that's been rotated is actually a frustrum. Kind of cool, huh? So if I were to flip this over, and I mean, obviously it runs off the graph, but I will do my best. Show you. And then if we keep rotating and rotating, see how the circles are on the sides? This is a terrible drawing. And there's your frustrum. It's just sitting on its side. So I'll kind of turn it so you guys can see it. So a 2D trapezoid that's been rotated around an axis becomes a frustrum. Kind of neat. So I'm going to have you guys find the volume of this frustrum, and then we will be done. So again, to remind you, the volume is pi times h over 3 times radius of the big circle plus radius of the big circle times little circle, and then little circle squared. Okay. So we do kind of need to identify what these things are. So I am going to turn it to make it easier to see. So what is the height of this frustrum? It's from here to here. So that's 1, 2, 3, 4, 5, 6 units tall. So that's my height. My big R is the bigger circle's radius. So from here to here or here to here. And that looks to be 9 units. And then the little circle radius is from here to here, and that's 6 units. So go ahead and simplify that out, and let's see what you got. Did it correctly? The volume of this frustrum is 342 pi. And you can put units cubed. Awesome. All right, so homework time. Homework up here. So we have so there's Mod 5 Day 1 homework, which is on pages 6 and 7. And then there's also Mod 5 Day 2 homework, which is on pages 12 through 14. So we are going to do both, but I'm just going to pick and choose a few that will equate to one homework, so don't worry. So on these 2 pages, Mod 5 Day 1, you're going to do number 1, 4, 5, 7, 8, 9, 13, 14. And then from Mod 5 Day 2 on these pages, you're only going to do 1, 4, 9, and 12. Okay, so that is your homework. And this is going to be due on Tuesday. What day is Tuesday going to be? The 21st by 4 p.m. All right. And then I will be on those virtual office hours on that same day, Tuesday. And then depending on what period you're in, so I'm going to be there at 8 a.m. to 8:55 for period 1, and then at 10:05 to 11 for period 3. Okay. You guys have a good day.